Hey guys, let's start with 5.2 this week. This is going to talk about trig functions in the xy plane. So when we're talking about trig functions, it's really nice to start out with the right triangle because we can easily see the Pythagorean theorem and how it's working. And when we have set lengths of sides, we see those side ratios, and it's a great way to introduce the trig functions. But we're going to look at them in a different light now that we hopefully have a grasp on the ratios and how they work and stuff like that. Because the problem with right triangles is that it only explains to us how to find trig functions of angles that are less than 90. Once you get to 90, a right triangle isn't helping you, right? Because you can't have a right triangle with an angle that's greater than 90. But we know there's tons of angles greater than 90. We've got 180 and 360 and 270. We've got tons of angles that we need to find trig functions for. So that's where our right triangle explanation kind of breaks down. And we want to get into the xy plane. So what I'm going to do is I am going to draw an angle in the plane. We'll call it theta. Notice, remember when we talked about angles in standard position? My angle is in standard position. It means the initial side of the angle is starting at the origin and going right on the positive x-axis. Remember, this is called my terminal side. And I want to find the trig function values for this angle theta. Notice I don't know what theta is, and that's okay. Sometimes I will and sometimes I won't. It just depends on the problem. So all I have right now to go on is the fact that trig functions are ratios of sides of triangles, opposite, hypotenuse, adjacent. So what if I could pick a point on this terminal side, drop a line down. I know it's not really there, so I've dotted it in, but if I drop a line down, can you see that we have a right triangle that we can work with? This would be the right angle here. So let's find some values. This point that I picked, because it can be any point, this is going to work for all points in the plane. I'm going to just call it xy, just general coordinates. Well, if this point is xy, then would you agree that this point here, so going to the right over to the edge of this triangle we created, would be going over x units. Because to get to this point, I have to go over x units and go up y units. So you could note that this on the y-axis would be up y units. So I've gone to the right x and up y, and I've landed at my point xy. All right, so we can see our triangle. If I want trig functions, I need ratios of side lengths. Okay, so let's talk about how to find these. This side length down here, the horizontal, or it looks like the short leg in this particular case. I started at the origin and I went right x units. Would you agree that this side has a length of x? Yeah, and would you agree that this, the up down, I went up y units, so this would have a length of y. So I have a side length x and a side length y. The only side length that I'm missing is the hypotenuse. And you guys, I'm going to call that r. We use r as the length of our hypotenuse now. And now we're going to create how to find these trig functions when you have an angle in standard position on the plane. All right, so let's start with the sine of theta. Remember, sine is opposite over hypotenuse. Our theta is this angle here. So it looks like y would be the opposite side of theta. And the hypotenuse I've called r. So the sine of theta for any angle in standard position in the plane is going to be y over r. So the cosine of theta. Remember, cosine is adjacent over hypotenuse. So the cosine for this angle theta would be x, that's the adjacent side, the one that's touching it, over the hypotenuse r. So we get x over r. Let's do the tangent of theta. Remember, tangent is opposite over adjacent, so that in this case would be y over x. Let's do the reciprocal functions. Cosecant. Remember that cosecant is the reciprocal of sine. So if sine is y over r, cosecant will be r over y. Secant. Remember, secant is the reciprocal of cosine. So take your x over r from cosine and flip it, and you get r over x. Lastly, we have cotangent. I know that's the reciprocal of tangent. So instead of y over x, it'll be x over y. So notice the ratios are still the same ratios. We still have opposite, hypotenuse, and adjacent. All we're doing here is labeling them with x, y, and r now because it helps us anywhere on the plane. We're in the xy plane. It's really nice to be able to label these lengths x and y. All right, so I would take a moment to write these ratios down in x, y, and r. And then we're going to move on and talk about something different. All right, so I have to erase this because I don't have a lot of board space. But I'm basically going to draw a plane again and give you some more information. Okay, so in this plane, I'm going to focus on quadrants. Think about the xy plane, how the axes split it up into 4 quadrants. And you probably know what the quadrants are. We start here in quadrant 1. Here's quadrant 2. Here's quadrant 3. And quadrant 4 is down here. Okay, so why are quadrants important to us? Well, if I know where my angle lies, which quadrant it's in, it's going to dictate the sign, so the positive or negative of my trig functions. Now, on our right triangles, remember we could only go up to 90. We didn't deal with any negative trig functions, but sometimes trig functions are negative, and I'm going to show you why. In quadrant 1, what do we know about both x and y? Starting at the origin, if we go right on the x-axis and up on the y, it means that every ordered pair in quadrant 1 is both positive x and positive y. In quadrant 2, x is negative, but y is still positive. In quadrant 3, we've gone left and down, so it means that both x and y are negative. But in quadrant 4, we're back to a positive x because we're on the right, but because we're below, oh, I just wrote x instead of positive. Hold on. Positive x, but a negative y. So again, you probably know these facts, but we are going to use them to our advantage. Okay, so let's start with the sign. Remember, sign in the ratios that I just told you is always y over r. We're going to find out pretty quickly in a couple of examples that r is always a positive value. Think back to a right triangle. When you're looking for the hypotenuse, it is a length, so it will always be positive. Okay, so let's note that r is always positive. All right, so y over r. Where would sign be positive or negative in each of these quadrants? Sign has a y and an r. Well, I know the r is always positive, so it'll really depend on what the y is. In quadrant 1, sign would be positive y over positive r, which means it would be positive there. So I'm going to start making a list, and my list will consist of the functions that are positive in each quadrant. So sine is definitely positive in quadrant 1. Let's think about quadrant 2, y over r. Look, in quadrant 2, y is still positive, and I know r is positive. So sine is also positive in quadrant 2. Let's look at quadrant 3 though. You guys, y over r. Y is negative in quadrant 3. And remember, r is always positive. So a negative y over a positive r gives us a negative value. So sine is not positive here, so I'm not going to write it down. It's negative here. What is sine in quadrant 4? Look, y is negative again. So negative y over positive r, sine's negative here also. So for sine, it's always positive in quadrant 1 and 2, but it's negative in 3 and 4. Let's look at cosine. Remember, cosine is x over r. So let's start from quadrant 1 again. X is positive in quadrant 1. R is always positive. So cosine is also positive in quadrant 1. But you guys, in quadrant 2, x is negative. So it means cosine is also negative. So I can't write cosine in quadrant 2 as being positive. Remember, my list is the positives in each quadrant. Quadrant 3, x is negative still. So negative x over positive r, cosine's still negative there. But you guys, quadrant 4, look at that. X is positive again. So if x is positive and r is always positive, it means cosine is positive in quadrant 4. Let's look at tangent. Remember, tangent doesn't have an r in it at all. It's just y over x. So in quadrant 1, where y and x are both positive, tangent will also be positive. In quadrant 2, y over x would be positive over negative, which means tangent would be negative there, so I can't add that. But what about in quadrant 3? These are both negative, so when you put negative y over negative x, what happens? It becomes positive, so tangent's actually positive in quadrant 3. In quadrant 4 though, we're back to two separate signs here, so we have negative over positive, and it's negative again. So you guys, these are which trig functions are positive in each of the 4 quadrants. If they are not on this list, which means if they're not positive there, then they're negative. That's a lot of trig functions in some of these quadrants that are actually negative values. Before we move on, I want to note that the reciprocal pairs share the same signage. So if sine is positive somewhere, cosecant will also be positive, because taking the reciprocal, just flipping something over, doesn't change its sign. So that means that I could add cosecant, secant, and cotangent here, all the reciprocals of those, which means in quadrant 1, all trig functions are positive. These are the angles that we can work with using a right triangle, so that makes sense. In quadrant 2, I just have a sign that's positive. Remember, that means its reciprocal cosecant's also positive. In quadrant 3, if tangent's positive, cotangent is also positive. And then for cosine, we would pair that with secant. So I know this is a lot of information to just remember, but we have a little saying, because we always have a little saying, if you can remember that all students take calculus, which I know isn't necessarily true, but it works for what we're trying to remember. Notice, this saying has 4 words. Each word coincides with a quadrant. All is for quadrant 1, students for 2, take for 3, calculus for 4. So it's already in order for us. So all, what does that mean? It means all functions are positive in quadrant 1. Let's look at the quadrant 2 words, students. S for sign. You guys, it tells us that sign is positive in quadrant 2, and I know its reciprocal cosecant comes along. Take, that's the quadrant 3 word. Which is positive in quadrant 3? Well, that's a T for tangent. So you guys, all students take. It's the third word, it's tangent. It means tangent is positive in quadrant 3. Calculus. It's our fourth word and it starts with a C. That tells me cosine is positive. So all students take calculus will tell you which functions are positive in each quadrant. If they aren't positive, they're negative, right? Okay, so let's do an example problem and help us learn these quadrant rules. All right, so you have problems like this on your homework for 5.2. It's the first topic that will come up. All right, so on this particular problem, it gives you some information about an angle theta. And on this one, it says cosine of theta is less than 0, but cotangent of theta is greater than 0. You have to tell Alex which quadrant theta is in. Remember, less than 0, that's just another way to say negative. Greater than 0 is another way of saying positive. So how can I answer this question? Well, I just need to find the quadrant where these two facts are true at the same time. So start with the first fact. It says cosine is negative. So I think, okay, I need to look at all the quadrants where cosine is negative. It's positive in the all quadrant, so positive in quadrant 1, and the calculus for cosine quadrant. So cosine is positive in both of these. So if I'm looking for a place where it's negative, it has to be 2 or 3. Okay, so that gives you a little information, but not enough to choose if it's 2 or 3. Then you look at the second piece of information. It says cotangent is positive. So I think, cotangent is one of those reciprocals. Well, let's think about its reciprocal tangent. Where is tangent positive? Well, it's the take, right? All students take. It says tangent is positive in quadrant 3, which also means cotangent is positive there. So there's only one quadrant where cosine is negative and cotangent is positive, and it would be quadrant 3 on this example. So you're just eliminating quadrants by the information it's giving. So you would say quadrant 3 is where this angle lies because of the way its trig functions have worked out. So let's look at one more like that. On this one, it says that secant is greater than 0, so secant is positive, but sine is negative. So secant, again, it's one of the reciprocals, but what is it the reciprocal of? It's reciprocal of cosine. So if secant is positive, it means cosine is also positive. Where is cosine positive? In the all, in the quadrant 1, and in the calculus, in the quadrant 4. So secant being positive narrows it down to 1 and 4 for us. Sine is negative though. Where is sine negative? Well, between 1 and 4, sine is definitely positive in 1. Everything is positive in 1. So it has to be quadrant 4 because in this quadrant, secant is positive and sine is negative. So I would say the answer to this one would be quadrant 4. So you'll have to answer some of these questions. They get easier because you start being able to know what's positive and negative where without even thinking about it, because we do use that fact a lot. So you have some questions like that. All right, so knowing which quadrant something's in is nice, but you guys, wouldn't you want to find, don't you think it's ready for us to find some trig functions for angles anywhere in the plane, not just the first quadrant? I think it's time. So let's check it out. So this particular example, as we work it, we're going to learn a lot of information about how to work all of these problems. This is a great teaching example. It says the terminal side of an angle theta passes through the point 8, 6. So this is the information it gives us about some angle theta. Again, today our goal is not to know what theta is. It really doesn't matter at this point. Today we're focused on the trig functions for the angle theta. So this is what we know about theta. And it wants us to use this particular set of information to find the sine of theta, the cosecant of theta, and the cotangent of theta. So that's a lot, right? So let's think about it. Let's draw a picture. So we had that picture that I made at the beginning with x, y, and r for a general case x, y, right? Well, this is going to be a specific case x, y. All right, so 8, 6. Let's go ahead and find that. 8 on the x, 6 on the y, and we get a point right here. What does it mean by the terminal point passes, or the terminal side passes through this point? Remember, all of these angles are in standard position. If it doesn't say that specifically, assume it. It means the initial side goes along the x-axis, and it means the terminal side passes through this point 8, 6. So here's our point 8, 6. And this side passing through it has created our angle theta. Okay, so given this information, this is what the angle theta looks like. How in the world am I going to find this stuff, right? Because all I have is an angle. Remember what we did in that first general example. I thought about a right triangle. Remember, this x unit is 8. This y unit is 6. So it's easy to see that this side down here is 8. This side here is 6. What am I missing? I'm missing the hypotenuse, or that r. I have x and y. It gave me x and y, but I still need r, because for sine, for example, I need y over r, right? So I do have to find r, but then I can answer these questions. How do you think I'm going to find r if I have these two sides? Because it's a right triangle, right? Because this is a hypotenuse, I think I can just use the Pythagorean theorem. And you guys, we absolutely can. So when you're finding r, it's really just using the theorem. I have x and y. So I know that the Pythagorean theorem is a squared plus b squared equals c squared. But instead of using a, b, and c, I'm going to use my x, y, and r. So I'm going to say, make sure you put the legs together on one side. I'm going to say I have x squared plus y squared equals r squared. Okay, so I'm solving for r. Let's put in what we know for x. X is 8, so 8 squared plus y is 6, so plus 6 squared equals r squared. Make sure you square these and then add them together. So you guys, we get 64 plus 36 equals r squared. Now add these two together and get 100 equals r squared. Square root both sides and get 10 equals r. Why is it just positive? Well, I already noted r is always positive. R is always a length. No matter where you are in the plane, r is always the length from the origin to whatever point your side is going through. Okay, so I know r is 10. You guys, that's a triple. Remember, 6, 8, 10. So if you have x, y, and r, you can find all the trig functions, right? You just have to remember which ratio is which. So let's note here, x equals 8, y equals 6, and r equals 10. And let's find the sine of theta. Remember, sine is y over r. So in this case, the sine of this angle theta is 6 over 10. Definitely reduce that if it's possible. Let's reduce that to 3/5. So here's the sine of theta. That's the first thing it wanted you to find. What else? Cosecant. There's a couple ways we could go about this. We could say, ooh, cosecant, flip this, right? It's the reciprocal of sine. It's r over y. So r over y is 10 over 6. Reduce that, and you get 5/3. So you guys, I would say that's the long way of finding cosecant in this case. Because we already had sine, we could have just flipped that over because it is the reciprocal. But either way, we still get 5/3. What's the last thing it asks for? Cotangent. So you guys, we haven't found tangent for this one yet, so we can't just flip it, but we can remember our ratio for cotangent. If you want to remember cotangent as the reciprocal of tangent, that's a good way to remember it. Tangent is always y over x. Cotangent is always the flip of that, x over y. So cotangent is x over y, so 8 over 6, but we reduce that to 4/3. So you have some problems like this. They're worded exactly the same way. It'll say the terminal side, blah, 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 passes through a point. You don't have to draw any pictures if you don't want to for these examples. This point it gives you will be x, y. Obviously, they're giving you an x value, they're giving you a y. This value will always be x, this value will always be y, and you will always use those x and y values to find r using the Pythagorean theorem. Once you have x, y, and r, you can find any trig function they ask for. So you'll do all these in the same type of way. You guys, those x and y values they gave, so they gave the 8, 6 that time. Some of those values might be negative. They might give you a point in a different quadrant, but the method works the same no matter what. If one of those coordinates it had given us was negative, I would still use that as x and y. I would still use that to find r. Your r will still turn out positive because of the squaring, right? And then just use that x, y, and r to find all your other ratios. So, what's nice about x, y, and r is that you can find these angles that are in different quadrants, because x and y can be positive, they can be negative. It really doesn't matter. X, y, and r ratios are still always the same. Okay, so let's look at this question. I don't know why I have it 3 on my list. I don't know if it's example 3 or not. But it's going to be example 3 now. Okay, actually this negative is right in front, and I want to be clear about that. Okay, this is the information about theta it gives us on this problem. All it says is that the cosine of theta is negative 5/8. What it wants us to find is cosecant of theta and also the tangent of theta. All right, remember, to find any trig ratio, no matter which one it is, x, y, and r. That's all we have to know, and we can find any of them. So in our last problem, it gave us a point that the angle went through. A point, of course, is x and y. So in that case, it'll always give you x and y, and then you find r. You guys, it's giving us a different set of information here. So it says cosine is -5/8. What's the ratio for cosine? It's x/r. So really, by giving us the cosine, it's given us both x and r. It gave us two different pieces, and we still have to find the third piece. So in this one, it gives us x and it gives us r. Where does this negative go? So it's just sitting in front, which means, oh, should I put it on top? Should I put it on the bottom? Remember what I said about r. R is always positive, which means that negative has to be up with the 5. So you'll always move the negative up to the numerator if you're looking at x/r, because r is always positive. Okay, so can you see that comparing these two ratios here, x is -5 and r is 8. So instead of giving us x and y, they indirectly gave us x and r. I can't find cosecant or tangent without knowing y. So I do have to solve for y. I'm going to do the Pythagorean theorem again. I know always that x squared plus y squared will always equal r squared. And just be careful about which information you have at this point. I don't have y, but I do have x. Now, this is our first one where x is negative. So let's be careful with it. Make sure you put any negative value in parentheses, because when you square it, remember that negative goes away. So I have -5 squared plus y squared equals 8 squared. So I've put in what I know. -5 squared is +25. If you don't catch that, if you leave that negative in there, your whole problem is going to be messed up. So really careful with the negative squared. So I have 25 plus y squared equals 64. I'm trying to get this y squared by itself, right? That's what I need to isolate. So I need to subtract 25 from both sides. So I'm going to bring it up here. I've isolated y squared. 64 minus 25 is 39. Not great with the arithmetic in my head, guys. I think it's 39. That sounds about right. All right, so if y squared is 39, I have to take the square root of both sides to find y. You guys, there's no rule about y being always positive, right? I have that rule about r. R is always positive. So when I'm square rooting and finding r, I know I don't have to worry about the negative square root. But you guys, didn't I find that there's some times where y is negative? Definitely a possibility. So when you square root, when you're using the Pythagorean theorem to find either x or y, you have to consider the plus or minus square root. So I'm going to write this as plus or minus square root of 39. And I'm going to leave it as the square root of 39 because I'm leaving my answers exact. If it wants it rounded, I would still leave it at this point and then wait to round it till the very end. But leaving it exact, we're here. Y can't be both things. Y is either positive or negative. I just have to find out from the information given which one it is. So it says that cosine is -5/8. X is negative. R is obviously positive. So you guys, where is X negative? X is negative in quadrant 2 and also quadrant 3. All right, guys, so I had to pause it for a second because I thought the question wasn't giving us enough information to find out if y should be positive or negative. And the way I wrote it, it wasn't. You guys, I left out a very important part of the problem. It does tell us this about the angle, but it also tells us that theta is in quadrant 3. So on these problems, it will give you one of the trig function values, but it will also tell you what quadrant we're in. You guys, without that information, I couldn't go any further than here. So that's why I was confused. I had left off a piece of information, but here we are. You guys, so y is definitely either positive or negative. How do we find out? We look at the quadrant it's in. In quadrant 3, think about our picture. You guys, in quadrant 3, x is negative and y is negative. So for our example, when we solve for this y, because it's in quadrant 3, I know it's the negative square root of 39. So you have to pick positive or negative, but you will be given enough information to decide that. Okay, so sorry for the confusion. It does give the quadrant on this problem. All right, so if I know y now, let's put it over here with our list with x and r, is negative square root 39. So I've got that written down. I'm going to erase a little bit here so I have space, but then we can find our two answers. Okay, so what we're looking for to begin with is cosecant. Let's think about cosecant. Remember, it's the reciprocal of sine. Sine is always y over r. So cosecant is r over y. Remember, I just found all three values, so I can just put them in here. You guys, so r over y. R is 8, and y is negative root 39. Remember, I can't just call it done here. I do have to rationalize. Now, before you rationalize this one, just to get rid of any confusion that may come up when we're multiplying the top and bottom, I don't know why I erased that equal sign. But you guys, let's put the negative out in front. This is positive on top, negative on bottom. Let's just put it in front. This fraction is negative. So another way to write this is just negative 8 over root 39. I think it would be a little confusing, like I said, to have the negative down here with the root when we rationalize. How do I rationalize? I do top and bottom by that root. So multiply the top and bottom by the square root of 39. And then you have your answer that you'll put in because it's rationalized. There is going to be a negative in front. It's going to be 8 root 39 over 39. So you guys, this is the cosecant of theta. So that's the first part of our answer. Now we need to find the tangent of theta. So let's find that. I need more space again. All right, tangent theta. Well, tangent is always y over x. So just plug in y and x. Y is negative root 39. X is negative 5. So you guys, the only thing we have to do on this one is cancel out those two negatives. So this is really positive root 39 over 5. No rationalization necessary because we don't have a root in the bottom. Remember, it can be in the top. So here's the answer for tangent. So we found all we needed to know on this problem. You have probably quite a few problems in this section where you are looking for either x, y, or r. If you, I would suggest while you're working these problems, have notes written down somewhere. Have all the ratios, you know, sine is y over r, cosine is x, so have those written in a list. And then also remembering that x squared plus y squared equals r squared, you can find the answer to all of these problems using those two things, the list of ratios and the Pythagorean theorem. So before I let you go, that one gave us a cosine. It gave us an x and r. What if it gave you one of the more obscure ones? Maybe it gave you cosecant. So if cosecant theta equals 5/4 and theta lies in quadrant 2, find cosine and cotangent. So same type question as before, but in that first set of questions, it'll give you the easy ones, the ones that are more common. It'll give you cosine, or it'll give you sine or tangent. In the second set, it's going to give you more than likely the reciprocal ones. So it'll say, here's cosecant, find the other two that I'm looking for. So you just have to be careful remembering your ratios. Remember, you got a list of ratios sitting next to you. What's the ratio for cosecant? You guys, remember sine is y over r. Flip it and you get cosecant. So cosecant is r over y. So if a problem gives you cosecant, what two letters is it giving you? It's giving you r on top and y on the bottom. Remember, if this fraction had been negative, I would have to assign the negative to the y because r is always positive. Okay, so if I have r and y, can I solve for x so I can find these? Of course I can. How do I do it? Well, I do it the same way I always do it. X squared plus y squared equals r squared. So I don't know x, so I have x squared plus 4 squared equals 5 squared. You guys, you might not have to go any further than this. Obviously, this is going to be a 3, 4, 5, but it's okay if you do. We keep solving. We get x squared plus 16 equals 25. Subtract the 16, and you get x squared equals 9. Remember, because we're looking for x, it could be positive or negative. So, when I do the square root and I get x equals plus or minus 3, I have to go back and reference what quadrant I'm in to know which is which. You guys, in quadrant 2, is x positive or negative? It's negative in quadrant 2. So it means that x that I'm looking for is the negative 1. Be careful about those signs. Remember, the quadrant will tell you if it's positive or negative. But if I know x is negative 3, I can easily find cosine and cotangent. You guys, if you have x, y, and r, you could find all 6 of them if you had to. Okay, so cosine. Remember, that's x over r. So in this case, negative 3 over 5. Cotangent. Well, cotangent is always x over y. Remember, it's the flip of tangent. So x over y, negative 3/4. And again, you could just keep going. You could find the other 4. Well, you already know that one. You could find the other 3 if you had to. This unlocks all of them, knowing x, y, and r. You just have to know, what are they giving me and what do I need to find? All right, so that should get you through 5.2, you guys. And next time we'll do 5.3. That will be it for the week. So make sure as you are doing these that you really are feeling prepared, doing problems from these sections to get ready for our quiz that opens on Thursday.